Hello and welcome to 9.1 Quadratic Graphs and their properties. Today's SWABAT is going to be to graph quadratic equations of the form y equals ax squared and y equals ax squared plus c. So we've already studied the quadratic formula, which is y equals ax squared plus bx plus c. The things I want you to notice is that there's no b term for this one or for this one. So they're a little bit simpler to graph. Quadratic function is any function of the form y equals ax squared plus bx plus c. Note the degree of this polynomial is 2. So anything that has the x squared or the variable squared is going to be a quadratic function. Standard form is going to be like this because you're going from the highest degree to the lowest degree. And a quadratic parent function. This is the one that we're always going to compare everything else to. That's f of x or y equals x squared. A parabola. The U-shaped curve that represents a quadratic function is known as a parabola. So it'll be like this, or it'll be like this. Axis of symmetry is a line that divides a parabola into two matching halves. So I could divide it by half right there, and these would be my axes of symmetry. Vertex. The vertex is either the highest point or the lowest point of a parabola. So for this one, because of the way that it opens, this would be my lowest point. And for this one, my vertex would be there because it's the highest point. Minimum is the lowest point, and this would be your maximum point, depending on if it opens up or if it opens down. So for this first portion here, label the axis of symmetry, the vertex, and determine if it's a minimum or a maximum value. So here's my parabola. My axis of symmetry, if you can see it, is this red line right here, and this is x equals 0. My vertex is here. This is a minimum value because it's the smallest point on here. So this is a minimum, and this coordinate is 0, 0. When we graph, we're going to have to do two things. We're going to label the axis of symmetry, x equals some number. Today, the axis of symmetry will always be 0, and the minimum value as well. Okay, so we have 3 graphs here for us to look at or to consider. The effects of A. A is that whatever number is in front of the x squared. So if you remember at the very top, it says y equals ax squared. A is whatever this number would be. This is the parent function, y equals x squared, and you can see in this graph, this is the function y equals x squared. This is your parent function right here. This is the parent. I don't know about you, but sometimes it's irritating to always be compared to your parents and what they've done, but that's what we're going to be doing today. And then in red here, I have the graph y equals 4x squared. So now the a, instead of being 1, the a is 4, and the graph is seen here. For part B, here's my parent function still, it's in black. And then here's the function y equals 1/4 x squared. As you can see, it looks a little different. This one compared to this one. And then, so for this my a equals 1/4, and for this my a was 4, and for this one in green my a is -1. And then for -1, this is what my graph looks like. So based on this, we can say a couple of things. If the absolute value of a, that just means whatever this number is, whether it's positive or negative. If it's greater than 1, then what's happening with the graph? Well, which one of these fits that description? It would have to be this one. And what's happening with the graph in comparison to the parent function? It's narrower. It's narrower. What if a is between 0 and 1, meaning that's a fraction less than 1? What's happening? Well, that's what's happening for part B, this blue graph here, and instead of being narrower, you would say that it is wider. When a is negative, so this is my green, what's happening? It is, you're not going to say flipped. I know most of us would like to, but we're going to say it's reflected. It's reflected. So instead of this way, it's reflected down there. It's like it's looking at itself in the mirror. Other comparisons we do is when we look at the effects of the c value. This would be the c value because it's ax squared plus bx plus c. So what's happening here? Well, here's my parent function still. It's in black as we've been doing for the other ones. And now when I did 2x squared plus 2, it is now up here. So my vertex was here at 0, 0. Now my vertex is at 0, 2. So what happened? This graph got shifted up. Well, what else do we know? Number one, it's shifted up. That's one comparison. The other comparison here is, well, let's look at it. It's a little bit skinnier there. So I'm going to go ahead and say that it's also narrower. Looking at part B, this comparison, vertex is lower. It's going down 1, 2, 3. So it's shifted down 3. Why? Because this was negative 3. This was shifted up 2 because the C was plus 2. So if C is plus 2, if it's plus anything, you're going to go up. If it's minus, you're going to go down. Then what? This is wider also, so I'm going to go ahead and say it's also wider. There you go. Those are your comparisons. Let's say C, C will shift your graph either up when C is positive or being added, or down when it's negative. That's what negative people do. They bring it down all the time. It's life experiences, guys. So here's our next one. Graph the function. This is where all the magic happens. For these, and then they also ask you to identify the domain and the range. So we're just going to make an XY table. I'm always going to use 0 as a nice user-friendly. Typically, guys, I'm going to use 0, 1, 2, and then I'll also use like -1, -3, -2, just kidding. But I see this fraction here. So I do still want to use 0, and I do want to use 1, but instead of 2, because I have 1/3, I'm going to use 3. And then instead of, I'm still going to use -1. Instead of -2, I'm going to use -3. Just because it's going to make it a little bit easier. 1 and 0, those are my go-to numbers because they're super duper easy. But instead of using 2, I'm using 3 here. So let's take a moment and plug each of these in. The easiest one is 0. Because what's 1/3 times 0? 0. That's grand. Now 1, when x equals 1, y is equal to 1/3 times 1 squared. Well, 1/3 times 1 is 1/3. And then I'm going to plug in 3. So that's 1/3 times 9. Well, 1/3 of 9, that's just like dividing 9 by 3, and I get 3. Now, I'm running out of space over here, so I'm going to plug in x equals -1. So I'll have 1/3 times -1 squared. That's 1/3. -1 squared is like saying -1 times -1, so that's just 1. That also is 1/3. Wow, what a coincidence. Based on this, you see this is 1/3 and 1/3. My prediction is that this is going to be 3. The reason why is because of that axis of symmetry is actually right here. So everything that happens here will also happen here. Let's plug it in and verify. So 1/3 times -3 squared. 1/3. What's -3 squared? 9, which is 3. It's delightful. It's because of, I just lost my lights. It's because of that axis of symmetry. My axis of symmetry is right there at x equals 0. So let's plug each of these points in. I have 0, 0. I have 1. Ooh, 1/3 is super duper low. And then I have 1, 2, 3. And then I'm supposed to go up. 1, 2, 3. I just did these ones instead. I like to do the positive ones first. Sorry about that. And then I have -1, 1/3, super duper low. And then I have -1, 2, 3, positive 1, 2, 3. 1, 2, 3, 1, 2, 3. Great. So I'm going to go ahead and connect these in the shape of a parabola, which is kind of like a U, making sure that this bottom part is rounded and not pointed. And then my vertex was 0, 0. The domain. Domain is my x values. And I can put positive numbers and negative numbers. This is going to keep going on from left to right. So my domain is going to be all real numbers. My range, however, is looking at this up and down. You see that your vertex here is a minimum value. That's the smallest that that's going to be, the y is going to be. The smallest value for y in this case is 0. So everything above it, y is greater than or equal to 0 because it goes everything above that. Okay. Now I'm going to also do an xy table. And I'm going to use my standard points. If I don't have a fraction, these would be my standard points. Always. Promise. Well, today. So the first one is 0. If I plug in 0 here, I have negative 2 times 0 squared plus 3. Negative 2, 0 squared is 0. Sorry. 0 squared is 0. So negative 2 times 0, 0 plus 3 is 3. So for 0, I get 3. Yep, I pretty much always start with the middle number there. So 0, 1, 2, 3. I notice that this is a negative number, which is telling me in my head that this should go downward like that. So I'm going to plug in 1. When x equals 1, y equals negative 2 times 1 squared plus 3. Negative 2 times 1 plus 3. Negative 2 plus 3 equals 1. So for 1, I get 1. Now, here's the thing. This is where your axis of symmetry is right here. Axis of symmetry all day today is right here. So that means if 1 is 1, then so is negative 1. Negative 1 is also 1. Okay, now this cuts my workload in half, doesn't it? So I have negative 2 times 2 squared plus 3. Negative 2 times 4 plus 3. Negative 8 plus 3 is negative 5. Which is great because this is going to reflect right up here as well. So let's plot those. 1, 2, 1, 2, 3, 4, 5. 1, 2. My vertex here is 0, snap, 0, 3. Yeah, this is not a negative, that's just my axis of symmetry. And we'll draw this in nicely as best we can, because some of us are new at this and some of us haven't done it in a while. Axis of symmetry is 0. X equals 0. That's how we graph those. So you're going to make an XY table, make sure that you label each thing, and the other thing that they asked me for is the domain for this one. And again, it's going to be all real numbers because I can put anything in there for x's. It's from left to right, it goes forever. All real numbers. In my range, now this time I have a maximum, and then everything goes downhill from there. So my y values is everything, the top of it is 3, but it's everything less than or equal to 3. Everything less than or equal to 3 for that. Okay, the next thing, last thing that they asked us to do is to order these from the widest to the narrowest. The widest to the narrowest. So from the other side of this. And we know that the narrower ones, if we're looking at this, are going to be the ones that have the biggest number. The biggest absolute value number. So I'm looking at this, and the absolute value of this would be 2. Absolute value of this one is 1/5. And the absolute value of this is 1. So which one is the narrowest? The one that has the biggest number. So that would be this one. It's not intuitive because I would think this 1/5 was super skinny and like to say that's 1/5 of the size of the other ones. Nope, not at all. So this one would be my narrowest, y equals negative 2x squared. And look for just whatever one has the biggest number. Next, y equals, well, which one? 1/5 or 1? 1 is bigger than this, so I'm going to go for this one is going to be my next one, negative x squared. And then finally, y equals negative 1/5, because we know that when you have a fraction, it's going to be super wide. And that, x squared, is our lesson. Thank you so much for joining me.